In our final lesson of the year, we're going to look at something called the quadratic formula. Now, we would use this formula because other methods for solving quadratic equations don't always work. So the factoring method that we've done before, it's neat and easy to do, but it doesn't always work. Whereas the quadratic formula does work. The only issue is that it's sometimes hard to see like where this formula comes from, and we didn't get into that this year. But we're going to go ahead and use it, and we'll see how we can use it to get to the x-intercepts. So the quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac, and all of that is divided by 2a. So let's look at how we can use it with the example of y equals 2x squared minus 3x plus 1. The first thing we want to do is we're trying to find the x-intercept, so we're going to set y equal to 0. We always want to do that because it won't always be written so that it's y equals. Right? We want to get in the habit of having 0 on one side, everything else on the other. The next thing we're going to do is we're going to identify a, b, and c. So a is the coefficient of x squared, in this case is 2. B is the coefficient of x, which here is -3. And c is our constant, which is 1. Now that we have those, we can go ahead and we can substitute our values into the formula. And this is where you got to be careful. So we're going to have our x equals the opposite of b. So we want the opposite of -3 plus or minus b squared. So that's -3 squared minus 4 times a, which is 2, times c, which is 1. And that's a square root. And all of that is divided by 2 times whatever a is, and in this case, a is 2. So there we go. We've got everything substituted. You have to be careful with things like this. Make sure that's in parentheses for when we square it. And now we can just go ahead and simplify everything out. So when I simplify the expressions under the square root symbol, we end up with 3, right? The opposite of negative is 3, plus or minus the square root of 9 minus 8, all of which is divided by 4. And simplifying that one step more, I end up with 3 plus or minus the square root of 1 divided by 4. Now you might be wondering, what do we do with that plus or minus square root of 1? Well, we have to break this out into 2 different problems. So we could either do 3 plus the square root of 1 divided by 4, and we can do 3 minus the square root of 1 divided by 4. So if we take the first one, the square root of 1 is 1, so this becomes 4 over 4, which equals 1. So our first intercept is x equals 1. And if we simplify the second option, we've got 3 minus 1, which is 2. So our second intercept is 1/2. So our x-intercepts are x equals 1 and x equals 1/2. And that's how the quadratic formula works. Let's look at our second example. So we have find the x-intercepts of the graph of x times the quantity x minus 4 equals 5. Well, in this particular problem, we don't have a y variable in it. And what we need to do is we need to distribute that x. So we're going to get x squared minus 4x equals 5. And remember, we want everything on one side and 0 on the other. So then we would subtract 5 from each side. And that leaves us with x squared minus 4x minus 5 equals 0. And now we can identify a, b, and c. A is 1, b is -4, and c is -5. Now that we have those, we can go ahead and use the quadratic formula. So it's the opposite of b plus or minus b squared minus 4 times a times c. All of that is under the square root, and we're going to divide everything there divided by 2 times a, which in this case is 2 times 1. When I simplify all of that in the numerator, we end up with 4 plus or minus the square root of 36 divided by 2. And now we can have 4 plus 6 divided by 2. And we can have 4 minus 6 divided by 2. So 4 plus 6 divided by 2, that's 10 over 2, which is 5. So our first x-intercept is 5. And our second one is -2 over 2 is -1. X equals -1. So there's our x-intercepts. So this is what you're going to practice today. If you have any questions, let me know. And good luck.